learners, welcome to Education Online program. I am teacher Willa Lucia. In our previous lesson, we learned about the thermal expansion of matter, where we say that it is the increase in the size of an object if this object is heated. So we went ahead and looked at expansioning of solids, how the solids are actually expanding, where we talked about the bimetallic strip. So we said with the bimetallic strip there are two metals that are combined together. So what happens with these two metals? We say that they have different rates of expansion. So if they have different rates of expansion, what happens? There will be deformation in the shape of the metals. So today we shall be looking at the uses of the bimetallic strip. So we're looking at the uses. Uses of metallic strip. So if we combine two metals, as we said, metals that are having different expansion rate. So how can we use these metals, which is the metallic strip? So after making the strip, we shall see that it is used in the fire alarm. We shall say it is used in the fire alarm. So you see that fire alarms, some of them are automatic. Why? Because of this existence of the metallic strip in the alarm. So let's take a simple look at the alarm. Let's see how this strip is actually being fitted in the alarm. So if we have our socket, our circuit, so this is right on top here. We shall have we assume that is our alarm. So we need the batteries, because in a circuit, of course, we shall need the batteries. So this battery here comes and then it's connected to what? We shall have our bimetallic strip connected to the circuit. So connecting this metallic strip to the circuit actually makes the circuit complete. So here we're trying to complete the circuit. So if this is the strips, this is containing two different metals. Let us have difference in the two. Maybe one like this. Then we have the downer one, the lower. Let's have just something like that to differentiate this, that there are two different materials. So you see that we are having this, they are of the same length. So we are going to have a contact. We need a contact here to come from the alarm here. So we shall have this as the contact. So this is our metallic strip. So how does this metallic strip actually help us to get the sound when there is heat? We see that when there is heat around, when this metallic strip detects any change in the temperature, if the temperature increases beyond, what happens is that it is going to expand. If it expands, what happens? It will increase in length. There will be, this one will actually increase. So when it expands, remember, it does not expand in this way, that it remains long like that, but then it expands in a curvy way. Why? Because one of the strips expands more than the other. If they were expanding at the same rate, you will see that they will just increase in length like that. But then for them to, this curving here is caused by the difference. So you see that if this outer one here, this metal we have used out, has a very high coefficient of expansion, what happens is it is going to make this metallic strip to curve inwards this way. So we shall have, instead of this straight thing, we shall have something like this. So you see that when it curves like this, meaning that it is going to hit the contact here. So when it hits this contact, what happens is that you will hear the alarm sounding. So this alarm is sounding because the metallic strip in the alarm, in the fire alarm, acts as the switch there. So the moment the heat increases under this, and then this detects it is going to expand. When it expands, it will make a contact with that. And this one, since it is making a contact, it will be acting as the switch. Then you hear the alarm making the sound. We also have another use of this metallic strip, where we said we use it in the thermostat. So you find a thermostat is a device actually that keeps the temperature of any appliance or a room constant. So how does the metallic strip actually work in the thermostat? So let us look at the thermostat. We have a simple diagram here of a thermostat. A thermostat has what is known as the control node, which we shall have it here. Let us have a bit perfect drawing. So we need to create a node. So if this is the control node, if it's the control node, where do we have the metallic strip? So this is connected to an insulator. We shall have our insulator right here. So you'll find out that our metallic strip is actually down somewhere. This one should continue like that. I'm going to have this down. This is, we are trying to create our strip there. So with our strip, we also have the contact. And then after the contact comes somewhere here. We shall have from under that shall have this, which is more like a nail with a sharp point end there. So we shall have this connected the other side. It should be a straight line. Mine is not straight because I'm not using a ruler. So I'll have it like that. So there is a contact here. This one is our contact point. So we have the whole of this as the insulator. With an insulator, we know that it's something that is that conducts heat poorly. So what of our bi-strip? We are going to have different shapes so that we can differentiate the two metals being used to create this metallic strip, like this. This one is connected to the circuit. And then this one is connected to the heater. This is our metallic strip. So this is the kind of a thermostat that is actually used in the electrical iron, because there is a charcoal box and then we have the flat iron. Those two are different. With the charcoal box, you see that you're going to make fire, and then when the charcoal is heated up, you'll get the charcoal and then put it in the iron box. But this time it is different. With the electric iron, we do not need the charcoal. So you see that there is a connection to the circuit. So this connection here will help us supply the heat to the system. So what happens is that if we want to use this under the iron box, so how will the electric iron work? So for this working of the electric iron, you need the whole of this. Since it is already inside the electric iron, you cannot see the thing that you can easily see from here is actually the control knob, because the control knob is just on top of the flat. The electric iron, that circular thing that you try to change to adjust to see the temperature of the iron is what is the control knob. So you see that at first you're going to adjust this control knob. You adjust it to the temperature required, because there is a temperature needed for ironing something that is made out of wool. There is for something made out of silk. They do not require the same temperature. So when you adjust this control knob to the required temperature, what happens is that as you're ironing, in case there is any other increase in the temperature, if the temperature continues increasing, because when you adjust this, there will reach a point where you see that there is change in the temperature of the iron. What happens is that increase in the temperature will be alerted. This one will immediately sense the change. So as the metallic strip senses the change, it is going to expand. So when it expands, what happens? It is going to break its contact. It will break its contact from the heater, because if it breaks its contact from the heater, there will be no more heat being sent back to the iron. So you see that the moment it breaks its contact, the iron is going to cool. So during cooling, it is also going to be waiting. This metallic strip, it will wait to sense that this heat is now below the adjusted, because remember you adjusted your knob to a given temperature that you need. So when this iron is reducing, if the temperature falls below what you adjusted, this metallic strip here is going to cool. So when it also cools, that means that there will be contraction. If it is contracted, what happens? It connects back. It makes its contact back with the heater. So when it makes the contact back with the heater and again senses increase in the temperature beyond, it is going to expand and breaks the contact. So this process continues until, so you see that when you decide to adjust also your temperature again from the control knob to a higher to a higher rate, this one will also weight the metallic strip as you're ironing. The moment the temperature increases beyond what you adjusted, it will just break the contact immediately. So that is how we use the thermostat in the flat in the electric iron. So it is also because of the provision of this, the metallic strip. So that is another use of the metallic strip there. So now, if we know the uses of this metallic strip, since we are talking about expansion in solids, what could be the disadvantages? Because what you're seeing here is more of the advantages of the of our expansion, of thermal expansion in the solids. You see that when it expands, there is adjustment in the temperature. It keeps that's why they're saying it keeps the temperature of appliance constant. So what could be the disadvantages of this thermal expansion? Let's look at the disadvantages. Of thermal expansion. We are going to look at the immediate one, which is the electricity transmission cables. Because you see, our electricity is not transmitted from one house to another, or from one point to another, just in space. We say that this one also requires a medium, transmission medium. So in this case here, we are using the cables as the transmission medium. So let's look at the disadvantage. We shall start with the electricity transmission cable. How is it disadvantageous here? The expansion of heat that causes the increase in the size of a thing. You see that when these cables are like tightened from one pole to another, let's take a look at this. We assume that this is our pole. We have this pole, and then we have another pole here. Imagine we have it tight like this. We have, this is, now this one here is the cable that transmits electricity from one point to another. If it is tight like this, what will happen? You see that if it is during cold days, it will be fine, because during cold days there is just a contraction. But then when it becomes hot, what happens? This one will expand, and when it is expanding, that means it is going to be creating tension. There will be very high tension in the wire, and you see that this cable can easily break. So expansion of heat can cause the transmission cable to break. So that is the reason as to why when you go outside to check how the cables are made, you see that the electric pole is right here, and then we have another pole. The cables are loose, they are just sagging like this. They are not tight from one point to another. They are kept loose like this so that it can provide space for contraction and an expansion of this wire. So that's why you see, during hot days, instead of you seeing it really sagging like this, you're going to be seeing it almost straight like that, because it has given it, there is enough room here for it to expand, so it will not just break, which is not the same case with that. So this is just the reason for this, for making it very loose like that, is to give room for the contraction and expansion of this cable during cold and hot days. So we have another one, which is on the railway. It can cause the railway to what? To buckle. It can cause the railway to buckle. How? You see the railway, if you look at the rails, they have not used woods. That is, if you come across any, maybe around a country where there are trains, try to check the rails. What have they used there? Did they use wood? No. Have they used plastic? No, they did not use the plastic, but then they used metals. So you see that it can cause it to buckle, because if these metals are not spaced during hot weather, you see that the rails will instead have this kind of shape, instead of being straight. This is the reason as to why, if you check the rails during their construction, there are spaces. If you go to any other railway, you're going to see that the metals have got spaces in between them. Why? The spaces are there to give room for expansion of these metals during hot weather, and there is contraction during the cold weather. So we have another disadvantages, which is now on the bridges. What will happen? The bridge can easily be damaged because of the effect of thermal expansion. Since most of the bridges are made out of what? They are made out of steel. So those steels also do what? They expand. Let's first write it here as it can damage a bridge. So our bridge is now made in a way that it gives room for contraction and expansion during hot weather. How is that possible? You see that the one end of a bridge is connected to, it is fixed, but then the other end is always placed on rollers, so it appears more like this. Assuming this is our bridge, there is one end here which is connected to this is our, my lines are not very straight, so let us see what happens here. So you see that one end of this bridge is going to be connected to, it is totally fixed. We can have it like this, totally fixed to the earth. But then what of this end? If the end is also kept fixed like that, will it provide room for expansion during when it is being heated? These metals, if they don't give them room for expansion, they are going to be damaged. So you see that a bridge is constructed in a way that instead of having both ends fixed, one of the ends will be placed on rollers. These are the rollers. You see that? So this is the reason as to why you see that they don't get damaged easily, because when it is expanding during hot days, you see that these rollers can just give them the free room to do that. Then during cold weather, they come back and they come back to their original sizes. So every time you're seeing that it is hot, that means that there is increase in the size of this of the metals that is being used for constructing the bridge. So that is how we design it, to reduce that kind of effect. Not that every time we have to be constructing our bridges. That's why we have it like that. So these are some of the uses of the metallic strip. Sometimes you don't get it as the uses of the metallic strip, but then they will tell you applications. Application of what? Of thermal expansion. When someone tells you about application of thermal expansion, this is also the application in the thermostat. The principle of of thermal expansion is applied in a thermostat. It is also applied in the fire alarm. So these two are actually the same. When they are talking about uses of metallic strip, so they are talking about the application of thermal expansion. So we have now seen the disadvantages of thermal expansion. Whenever something is increasing in size and you don't give it the space, you obviously know that it can easily be damaged. So these are some of the disadvantages. They are not just limited to this, but there are more out there. So with this, we come to the end of our lesson. We shall talk more about the thermal expansion in our next lesson.